What's up guys, this is Massey. Welcome to another video. In this video I want to show you how to find out the transpose of a matrix. So first of all, let's take a look at the concept of transpose of a matrix. If A is any matrix and the matrix obtained by changing its rows into the corresponding column is called the transpose of A, and it is denoted by AT. So it means that if we change the rows to columns or change the columns to rows, we call it a transpose of that matrix. So two notes right away: a transpose of a m by n matrix is gonna be n by m. Since we are changing the rows and columns, the number of rows, it was m, now the number of columns is m, the number of columns was n, and now it is n. And second note is the ijth element of AT is gonna be jith element. So basically you just flip the order of this index there. Let's take a look to the example. Here it says find the transpose of a matrix. Here it is a 3 by 4 matrix because we have 3 rows and we have 4 columns. So if we want to find out the transpose, so since it was 3 by 4, I'm expecting to have 4 by 3 matrix. So I'm gonna have 7, -1, 6, and 2. Then we have 3, 5, 1, and 6. Then I have -1, 0, 4, and 8. So that's how we write the transpose of a matrix. Next example, here we have a vertical or column matrix. We have 5 rows and we have 1 column. So it is basically 5 by 1 column matrix. So AT is gonna supposed to be 1 by 5. So I'm gonna have a row matrix, which is gonna be -1, 4, 0, 6, and 8. So that's the transpose of this matrix. Let's take a look to the next example. This one is 3 by 3 matrix. So the transpose of this matrix is gonna be 3 by 3 as well. So it's gonna be AT 5, 3, 9, 0, 2, -3, 0, 6, 0, 6. Now the funny part is this matrix is upper triangular matrix because all the elements below this diagonal is 0. So that's called upper triangular. And the transpose of it is gonna be lower triangular matrix. Next one, we have a matrix which the diagonal are 1 and all other elements are 0. This is called identity matrix. And since it's 4 by 4 matrix, we call it I4. Now let's find out the transpose of it. See, since 4 by 4, the transpose of it is gonna be 4 by 4 as well. So it's going to be 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. So as you see here, the transpose of the matrix is the same as the original matrix. So we can say that for identity matrices, the transpose of the matrix is equal to the original matrix. Now let's take a look to 4 notes. The transpose of a transpose of matrix is going to be itself. So transpose of a transpose of A is itself. ATT equals to A. Then KA, the transpose of KA equals to K times transpose of A, where K is the scalar. And when you have A plus B or A minus B, and we find out the transpose, that's going to be the same as transpose of A plus minus transpose of B. And at the end, A times B, the transpose of A times B equals to transpose of B times transpose of A. Here in this example, it says find the transpose of this matrix. As you see here, we have 3 by 1 matrix, so the transpose is going to be 1 by 3, so it's negative 5, 4, and 4. And next one, given the matrix 2 by 3, find out the transpose of this matrix, which is going to be itself. So I'm just going to write the original matrix 6, 3, negative 4, 2, 1, negative 3. That's the transpose of matrix, which is going to be the original one. Next one, given the matrices y 2 by 2 and x 2 by 2 matrix, does transpose of y minus x equals to transpose of y minus transpose of x? So it's going to be y minus x is going to be negative 4, 2, 2, negative 7, minus 4, 4, negative 1, negative 7, negative 4 minus 4, negative 8, 2 minus 4, negative 2, 2 minus negative 1 is going to be 3, negative 7 minus negative is going to be positive, so it's going to be 0. Then you need to find out the transpose of y minus x, which is going to be negative 8, negative 2, 3, and 0. On the other hand, we need to find out if the transpose of y minus transpose of x is the same as this guy. So y transpose of y minus transpose of x is going to be negative 4, 2, 2, negative 7, minus 4, 4, negative 1, negative 7. So that's going to be negative 4 minus 4, negative 8. 2 minus negative 1 is going to be 3. 2 minus 4 is going to be negative 2. Negative 7 minus negative 7 is going to be 0. So if you compare these two, you're going to say we have the same answer. So the transpose of y minus x equals to transpose of y minus transpose of x. Next example, it says find this matrix plus 3 times the transpose of this matrix. So this one is 2 by 1 and here is 1 by 2, but since we're looking for transpose of it, it's going to be 2 by 1. So it's going to be 4, 3 plus 3, 5, negative 4. So that's going to be the transpose. So that's going to be 4 plus 3 times 5, 3 plus 3 times negative 4. That's going to be 19. Here is going to be negative 9. Next one. If we have 3 by 2 matrix A, then what is 3 by transpose of A? So that's going to be 3 times transpose of A is going to be 2 by 3. 1, negative 2, negative 1, negative 2, 3, negative 4. That's going to be 3, negative 3, 9, negative 6, negative 6, negative 12. That's going to be the answer. So basically we found the transpose of this matrix, so that's why we have this 2 by 3 matrix, and then we multiply it by scalar 3, which we need to multiply all the elements here in this matrix by 3. Next one, if this matrix, which is 3 by 3, is a symmetric matrix, then find out the value of x. What does that mean when we are talking about symmetric? Symmetric matrix, saying that when the transpose of a matrix equals to the original matrix, we call it a symmetric matrix. So I'm going to write down the transpose of it, which is going to be 0, 2, 5, x 0, negative 3, 5, negative 3, 0. That's going to be equal to 0, 2, 5, x 0 negative 3 5 negative 3 0. So if you compare it, x must be equal to 2. So that's how we find out. I hope you enjoyed this video. Please leave me a comment if you have any question, and I get back to you as soon as possible. Please don't forget to subscribe this channel. You can have access to many other videos regarding matrices and other topics in algebra, calculus, physics, and chemistry. Thank you for watching and have a great day.